Okay, we'll just make the official announcement. It's the Keshe Plasma Reactor Group for Tuesday, December 8th, 2015. And welcome, everyone. And we'll see as we go here. Let me just get my camera on so I can say hello. I think if it's working. Yes. Hello, everyone. That's me. And yes, it's the Keshe Plasma Reactor Group into something like year 3, coming up on year 3 here shortly. All right, so we were just discussing with John here a bit about his nice little coil drawing in 3D. Do you want to put that up again, John, so we can have a look at it?
Yep, I'll bring that right up. So what I've been doing, I'm working on an actual proper technical drawing for the reactor, the power system, and run into a bit of a snag right here in this area, trying to get the end of this wire to meet up with this little spline right here, so that I can run the wire back around through and come back out. It'll be the same issue with this one as well. These are right now just the gravitational coils, just the small inside coils. I haven't put the magnetical coils on here yet because they're going to be pretty easy to do. But yeah, this will be great for the manufacturers if I can pull this off, and because the engineers will be able to look at this and it's in their language. They'll know exactly what we're talking about rather than the what I would call a scribble on a napkin, which is basically what we're working with right now.
The old scribble on a napkin technique, yes. So, can you make a wire that follows your spline on the inside of the inner coil there, and it would be like a more or less a almost complete circle, but not quite complete circle, and then join the ends from
Pretty much.
there.
That's pretty much what I'm looking at. Let me bring up the. Let's go to the southeast. We'll look at that end of it, and right here you can see I've already got a line coming from the center of this circle
Right.
here down onto a spline, which meets up with the end of this circle here, which is
Mm-hmm.
going to extend this down and back around through. But the problem I'm having is adding this arc and this spline right here together so they'll act as a path. And I just see another issue. I got another issue with the end of this spline I'm going to have to fix. But as soon as I solve that problem, I'll be able to basically take this wire and bend it around this path right here, back around through, and it'll come out at this point. At which point I'll add a 90 onto it and run it out, and that'll be the gravitational coils are finished.
Interesting. Yeah, and that looks good. Looks good.
Your John, your arc um, might be the radius might be too small. It's hard to see from this view angle.
According to the math, because the radius of the wire is 0.031, that arc is slightly larger than that. So it AutoCAD should be able to make the turn. It's deceptive here. This arc ends about the midpoint of this lower wire, like the outside edge of it's going to be about halfway
Mm-hmm.
equal to the radius of that wire. And then this spline comes back up towards the center along this arc here. That's
Right.
why I was saying earlier that it's on different normals. This arc, the normal is 10 degrees off of this line, so it's kind of sitting, it comes out and towards the center this way, which makes its z normal about this direction here. And then this one comes from down below Z0, which is this line, up to Z0 up here, and it's AutoCAD's having trouble reconciling the two different planes of construction planes.
Could
But I'm
you Could you use arcs instead of spline?
That's one thing I'm going to try to do. I'm going to try to do the whole thing in a spline if that works. If not, then I'll just make it in a bunch of small arcs,
Yeah.
adjusting my construction plane for each arc, which is a really tedious way to do it. Um, and it's not going to be real smooth. It won't be nice and smooth like these coils are. It'll be kind of chunky and have weird angles and stuff. But that may be the only way I'm going to be able to get this drawing done. I don't know. I'm gonna keep working on it and put another week into it and see what I can find out. It took me a long time to figure out how to get AutoCAD to first of all wrap a helix around a path, and then once I got that done, then extruding a circle along that helix was actually pretty easy. But I don't know. I think it looks pretty good, and once I get it done, it's going to be a nice drawing.
Yeah, it looks good. And the great thing about 3D is you can make 3 layers really easy.
Oh yes, oh yes, and I can make these two coils separate. I'll make the two gravitational coils or magnetical coils separate, and then I could just copy them and paste them on because I have the center of the array right there. So as long as that center remains the same, I can just layer these things and it'll be so easy. And then I can also cut these. I can take them and cut them. Just carve the top off of this, so you can look down from the top and see all the inner workings, and it'll be so easy to do once I get these little issues figured out.
And then we'll just add plasma and we'll actually have a working 3D drawing.
That's right. And it'll the engineers, any machinists or engineers, they can take this drawing and they can actually scale it. They can put their scales on it or calipers or whatever and know exactly what the sizes are. I can annotate it, give them sizes right on the drawing, put all the dimensions and everything on here, and then there simply won't be any questions. They'll know what they're building.
Right, a true blueprint.
Yeah.
Yep, that'll be a nice addition to the mix. Go ahead, sorry.
Are you going to make 2D drawings out of this 3D model, John, for manufacturing?
Well, I can show you what's going to happen if we look at if I take what I've got and let me see, where is it? It's in view. No, it's in home. If I take this and come on, there we go, and convert it to, there's a 3D hidden. If I go to a 2D wireframe, that's what you see. Which I understand what I'm looking at, but you're not going to know that that's a wire going around. So I was trying to keep it as much in the 3D view as I can, because I can still do my annotations and dimensions and stuff with the 3D view. It just makes a lot more sense to see it this way.
Yeah, but typically for manufacturing, they work with 2D drawings. They do cross-sectional views and different top,
Yeah.
side view, bottom view, things like that. And they use usually the 3D view for um, clarity, how the part looks at the end, but usually use the 2D views with dimensions for measuring and checking. So
Yeah,
you
we
may
can. I can bring this up in a single, like a 2D top view, which is going to look exactly like what you're going to look at if you have the thing sitting on a table and you look straight down at it.
yeah.
Um, if I take that and I take the 3D ax or 3D off of it, it doesn't make a lot of sense.
Yeah.
You see what I mean?
Yeah, well, SolidWorks is more preferred for these types of things because it will automatically create your 2D views out of your 3D model. You can have it in shaded or non-shaded form.
Yeah.
So you could if you could port this into SolidWorks, I think it
I
would
mean,
be a lot easier for you.
theoretically that would work because that's, when I was doing the tool and die work, this is more or less what I would have expect to see from something like this.
Yeah, that's a
Yeah,
good 2D drawing there. That
Yeah,
looks quite 2D look. I mean, like a blueprint, regular blueprint type look.
yeah,
you probably don't have to be too concerned about getting your that arc and spline perfect, because in your 2D view it will show up pretty good
yep.
here.
Yeah, and I'm thinking of consistency for between the manufacturers, so that when they bend a wire and make a certain shape in the wire, they're pretty much making them all the same. Just so that we don't have we get 15 manufacturers, we got 15 different ways that they hook these things together and 15 different configurations in how the wiring goes. I think we're looking at some significant issues if we don't standardize at least somewhat. So that's my concern anyway. It may turn out to be nothing, but um, I want to try to mitigate as many problems as I can see right off the bat. And if they don't turn out to be nothing, that's fine. It's a great exercise. I learned how to wrap a helix around a path.
Yeah, you did it in your mind. You might say you had to visualize it to get the program to work with you, and
Yes.
other people are doing it in the physicality. So it's actually sort of a step above the physicality to be working with it that way, in a sense.
Yep. And if there are other artists out there, there are other programmers that want to take this on and do it, by all means. I'm not devoted to the project. Well, I am devoted to the project, but I'm not wrapping my existence around it. So if somebody comes up with a better one than I can do first, more power to
I'm sure there's
them.
people out there that could solve that issue that you're dealing with now and know how to, readily um, integrate the two parts as far as that goes and so on. And also the files would be transferable to other formats such as I use Rhino, for example. It would probably transfer to Rhino and it could be played with in that format as well and some other of the 3D computer programs.
Yep.
So, yeah, it's a great beginning. Nice work.
It's a good start, all right. We'll see how it goes.
Yeah, I'm thinking along the lines of how to simulate the plasma flow, and I've been thinking for a while how to kind of approach it, what to use as a simulation for plasma, like heat or not really electromagnetic, because I have access to simulation software that I
I think
can't figure out.
the closest that I've seen would be electrostatic, um, what they call electrostatic or electric fields, perhaps, along with magnetic. But the magnetic programs are a little clunky. Most of them are more strictly magnetic type fields rather than magnetic gravitational type fields, of course. So, um, yeah, how to depict it as in an animation or some sort of picture? It's a good
Not an
question.
animation, but actually a real simulation, uh, uh, sort of simulating the flow, maybe like fluid dynamics. Um, but
Right, but you end up with an animation at the end of it that's based on physics, but it's still an animation. Um,
yeah,
yeah, and um, well,
but
there are programs that work specifically with plasma, and even down on the nano level for developing chips and other
mhm.
electronics.
Yeah,
And
yeah, I think console does that. So maybe I'll try it as a plasma.
the modules are probably $5,000 to $10,000 a piece or something to plug into your 3D program. but sometimes they can be accessed or played with for amateurs, for educational purposes, as we say.
Exactly.
Okay, what else about that? Anybody have something to show here? I've got a blank screen. I need to have some something interesting to show here. I don't have anything offhand. I can't remember what to put up. Well, I could show my video, I guess, and show a couple of things.
No,